Okay, so let's now consider P2. So since mag-consider naman to sa P2, and by the way, I have already placed here the beam, mag-consider na to sa P2 together with the resultant. So let's examine. If the distance from the resultant padung sa reference line is part x, which is 5 meters, and then the distance between 25 and 15, which happens to be at the reference line, is 2 meters. Therefore, the distance between the resultant and 25 is part x minus 2, which is 3 meters. No? So that's 3 meters. Basically, we're gonna divide the 3 meters distance between the 25 or the P2 and the resultant. That's 1.5 on both sides. And then we're gonna place it at the center line of this structure. So I'll make a center line. So I'll just cut or erase some of the lines para you can create a broken line, and this represents the center line, and that divides 12 meters into 2 parts, 6 meters on both sides. Next, I'll place the resultant. So the resultant is at the right side and 25 is on the left side of the center line. So right side. So the resultant here, 1.5. So I'll just place here the 1.5. The 90 resultant. The distance here is 1/2 of 3. It's 1.5. Then also, I'll be placing the 25 here. And the distance is also the same, 1.5. This is 25 kilonewtons. So if this is 1.5 here and this is 6, we still have 4.5 distance. But what is the distance between 25 and 15 na load? So 25 and 15 na load measures 2 meters apart. So basically, nagyapon si 15 sa system. So I'll just place here 15 here. This is the 15, and the distance between the two is 2 meters. So therefore, this distance padong diri sa 15, it's 6 minus 2 minus 1.5. That is 1.5. Sakto? No. That's 2.5. Is that 2.5? I'm questioning myself. So that's going to be 6 minus 2 and 1.5. So that's 2.5. Although dili kayo siya proportional. So that's 2.5. And then on the right side of 90, what is the distance between 90 and the resultant? 3 meters, no? So 3 meters. So I'll place here the 50. Here. I'll place here the 50. And then the distance between the two, this is 3 meters. So therefore, ang distance ani is 6 minus 3 minus 1.5. So yes, karon 1.5 na gid siya. Hindi na siya masuwat. Okay. That's 1.5. So anticipate na lang nato that we will be cutting the beam here later on. So asa man nindot i-consider, left or right? So left na lang. So solve na to si R1 di. So let's solve for R1. ay sa ikat ang beam. Summation of moment about R2 para ma-solve si R1. So you have R1 times 12. And again, instead of using the 15, 25, and 50, we have to only use 90. Kaya mauna siya ang resultant sa tulo. And then, the moment arm of 90 padong sa R2, that's 1.5 and 3. So that's 4.5 times 4.5. So R1 now is 90 times 4.5 divided by 12, 33.75. Okay, this is the R1. Karon, we're gonna cut this portion here of the beam and only consider this. So let's redraw the figure. So i-draw na to ang figure without the 25 kay diha man ta nag-cut. So I'll place here the R1. Then I'll also place 15. No? So by the way, the cutting here, the distance of cutting, padong diri, the distance here is pila man? 6 minus 1.5. So that's 4.5. So this is 4.5. And then I'll be placing the 15. Do not forget that 15 is included sa atuang cutting, no? Kaninga portion. So naa si 15. And then, of course, this is 2.5 based sa atong understanding ganina. Kana? And therefore, this leaves here as 2 meters. And then we're now going to proceed with providing M2. The direction, again, naman ta sa right side, it should be counterclockwise. Then let's now have summation of moment about the point of cutting at point M2. That's equal to 0, clockwise positive, counterclockwise negative. So you have to start with R1 times 4.5, then minus 15 times 2, and then minus M2 equal to 0. Transpose M2 to the other side, we'll have M2 equal to R1 nga 33.75. 0.75 times 4.5, and then minus 15 times 2, and we now have M2. So that's 33.75 times 4.5 minus 15 times 2. It's 121.875. It's 121.875. This is in kilonewtons. It's not writing again. And this is our answer, but not the final answer yet. Proceed with considering P3. How do we consider P3? So all we have to do is draw again the figure. So next paper na lang ta. So here, this is consider P3, and that is equal to 50. And we're going to redraw the figure. Here, this is the figure. Then we're gonna place the center line. And ato lang siyang i-cut para mura siya broken line. Okay, so this is the center line, and now this is 6 meters, and then 6 meters. So the distance between the resultant and 50 is 3 meters. So if we're gonna use that, 50 is on the right side of the center line, and RT, or the resultant, is on the left side of the center line, with 1.5 on both sides. So I'll place here the resultant. This is 1.5 kay 3 meters man silang duha, ilahang distance between. And then I'll place here the 50, and then the distance also is 1.5. Next, we're gonna place the 25. So 25 is 3 meters away from 90. So 3 meters away from 90, maybe it's found here. This is 25. So this is 3 meters. And if we have 6 together with 1.5 and 3, ang nahabilin is 1.5 na lang. Sakto? 6 minus 3 minus 1.5. So this is 1.5. But P1 from, or 15 from 25 na force is 2 meters, no? But we only have 1.5. So naitabo, this is the location of our 15, and this is 2 meters. And as you can see, 15 is no longer part sa beam. So karon, the resultant now of the force in the segment is no longer 90, but rather this and this lang. Kay mora man ang nabilin sa beam. So therefore, we're going to recompute the resultant without the 15. So recompute the resultant with only 25 and 50. So I'll just draw the whole figure. I mean the system kung unsay naa nagpatong. We only have 25 and 50. Then this is 6 meters. So moto siya, nagyahapon sila sa nagpatong. Okay, so let's recompute the resultant. So computing the resultant, the new resultant, it's going to be the summation of forces vertical, and the new resultant, it's 25 and 50. So the new resultant is 75 kilonewtons. So since naman tayo bagong resultant, might as well get the location of the new resultant. So I'll place here as barred x prime. Okay, so same sa atong gibuhat sa example number 1. So it's going to be the resultant, new resultant, and new barred x is equal to P2 x2 plus P3 x3, wherein x2 now is 0. Kay si x2 na naman siya sa atong reference line. Mo naman na atong reference line. And then x3 is 6 meters. So let us substitute you have 75 times bar x prime equal to, this is 0 anyway, x2 is 0, then plus 50 times 6. So bar x prime, new bar x, it's 50 times 6 divided by 75. It's 4 meters. So it's 4 meters. So the new resultant together with the 50 mo na itong i-consider. So let's redraw the whole figure with the new resultant. So here is our new figure minus the P1, no? And then let's redraw the center line. So redrawing the center line, and then atong deleton para broken line. This is the new center line. This is the center line. Then now we'll only be considering the resultant and this one, the new. So what is the distance between the two? This is 6 minus bar x prime. It's 6 minus 4. So this is 2 meters. So between the two, it's 1 meter. So ibutang na to that this is the new, and this is somehow equal to 75. And then I'll also place, by the way, this is 1 meter, and then the other one, this is 50, also 1 meter. And do not forget that you still have 25 niya naa sa bar x from the resultant, left of the resultant. So if this is 1 meter, and by the way this is 6 meters, so the 25 is found 4 meters. So this is 25, and the distance here, this is 4. So therefore ang distance ani, it's 1 meter, no? Para 1 plus 4 plus 1, it's 6 meters. Sakto. And then since we will be cutting this portion here, then it's better to solve for R2. So let's solve for R2. Do not cut the beam first or yet. So summation of moment about R1 para ma-solve si R2. So you will have negative R2 times 12. Then we'll only be using 75 because mo na siyang resultant. And then that's wala din ako siya gilahos. Ako din siyang gi-equilibrium. That's 75 plus 75 times pilay moment arm. That's 4 plus 1, 5. Equal to 0. Anyway, transpose this to the other side, it will become positive. So 75 times 5 divided by 12, it's 31.25. 31.25 kilonewtons. And then we're almost done. We're going to cut now this portion of the beam and consider this right side, since that's the simpler figure. And let's redraw the beam. Okay, then do not forget that naatay R2 dira. And the point of cutting here, by the way, if this is 1 meter and this is the whole length here is 6, therefore this is 5, no? So this is 5 meters. And we're gonna create a moment, and this moment is M3. Since naman ta sa left side, then it's going to be clockwise. So we're now ready by getting the summation of moment at point 3 or at M3 equal to 0. So you will have M3 as positive minus R2 times 5 equal to 0. Then transpose R2 to the other side. It's 31.25 positive times 5. Then M3 is 31.25 times 5. The answer is 156.25. 156.25 kilonewtons meter. This is our M3. So let's examine. Our values, as you can see, M1 is 91.875, M2 is 121, and then M3, it's 156. So it's obvious, no? You choose the biggest value. So again, ato sang i-summarize, M1 is lesser than M2, and that M2 is lesser than M3. So pila ni 91.875. So it's 91.875 lesser than here 121.875, 121.875, and lesser than 156.25. Therefore, Mmax is equal to the largest value, 156.25 kilonewtons meter. And this is our maximum moment. And this ends our example number 3.